first video on quadratics, and it's on quadratic graphs. Before we do that, we're going to look at some equivalent expressions. If we expand x plus 7 times x minus 3, we get x squared minus 3x plus 7x minus 21. You can then combine the minus 3x and plus 7x to plus 4x, so you get x squared plus 4x minus 21. And that means that x plus 7 times x minus 3 is the same as, is equivalent to x squared plus 4x minus 21. Similarly, you can expand x plus 2 squared minus 25. X plus 2 all squared is x plus 2 times another x plus 2. If you expand that, you get x squared plus 2x plus 2x, so that's plus 4x, and then plus 4. So you get x squared plus 4x plus 4 minus 25. And again, that comes to x squared plus 4x minus 21, because plus 4 minus 25 is minus 21. So that means that all three of these expressions are the same as each other. X plus 7 times x minus 3, x plus 2 all squared minus 25, and x squared plus 4x minus 21. However, they each show us different things about the graph. The factorized form, y equals x plus 7 times x minus 3, is really good for showing us the x-intercepts. The x-intercepts are where y is 0, and if y was 0, then either x plus 7 would be 0, and x would be minus 7, or x minus 3 would be 0, and x would equal 3. The completed the square form is ideal for showing us the vertex. And so, in this case, the vertex is going to be the lowest point on the graph. Well, that occurs where the x plus 2 all squared is 0, because the lowest that anything squared can be is 0. And so, if you have x equal minus 2, that makes the x plus 2 all squared 0, because you get minus 2 plus 2 is 0, 0 squared is 0, and then you get 0 minus 25, so the y-coordinate would be minus 25. So if we put in x equals minus 2, you would get y equals minus 25. If you put x in as anything other than minus 2, then when you add 2 and then square it, you're going to get something which is above 0. So for instance, if I put an x in as minus 3, I go minus 3 plus 2 is minus 1, but then when I square it, it becomes plus 1, and 1 minus 25 would be minus 24, so it would be a bit higher than minus 25. So the completed the square form is very good for giving us our vertex. And you'll notice that for the vertex, that what you do is you've got your plus 2 becomes minus 2 there, because you want to put in minus 2 to get that 0, and the minus 25 gives me the y-coordinate. The expanded form is really good for where the y-intercept is, because you see it there straight away. The y-intercept is minus 21, but you can also get that very quickly from the others, because it's just saying the y-intercept is where x is 0. If I put x is 0 into the factorized form, I get 0 plus 7 is 7, 0 minus 3 is minus 3, 7 times minus 3, minus 21. If I put 0 instead of x here, I get 2 squared, which is 4, take away 25, is also minus 21. So I can get the y-intercept very easily from any of them. And what this means is that the factorized form, which gives me the x-intercept, and the completed square form, which gives me the vertex, are more useful than the expanded form, which only gives me the y-intercept. Right, now let's have a look at some graphs. But what we're going to do is we're going to start with the standard graph y equals x squared, and then we're going to see what happens when we move that graph by using a translation. And the rule is this: if you translate by vector AB, then you replace x in the expression by x minus a, and y by y minus b. So if I start off with y equals x squared, I will replace the y by y minus b. Well, b here is 3, so I will replace the y by y minus 3, and I will replace the x by x minus a, in this case x minus 2. So I will get, instead of y equals x squared, I will get y minus 3 is equal to x minus 2 in brackets all squared. And of course, if I want to, I can move a minus 3 to the other side, so I get the equation y equals x minus 2 all squared plus 3. And so if I do that, translating it by 2, 3, and so if you look at the original vertex of y equals x squared was at 0, 0, if I move 2 to the right and 3 up, you'll see the vertex has now moved to the point 2, 3. And you'll also see if I wanted the y-intercept, I just put in x equals 0 into this, which gives me minus 2 all squared. And if I square minus 2, I get plus 4, plus 3 is 7. So you see my y-intercept is 7. Now, if we compare the vertex with the equation, what you will see is that if you've got x minus 2 all squared plus 3 has got a vertex at the point 2, 3, so y equals x minus a squared all squared plus b has got a vertex at a, b. In this case, my a was 2 and my b was 3. So what if I want to sketch a graph showing the vertex and the y-intercept? Well, firstly, let's look at the vertex. Well, the vertex of x minus a all squared plus b is at ab. So the vertex at x plus 4 all squared plus 5, a will equal minus 4, because if I do x minus minus 4, that comes to the same as plus 4. So that one we change signs from plus 4 to minus 4, and the b is going to be 5. So my vertex will be at minus 4, 5. Now, if I want to find the y-intercept, all I do is I put x equals 0 into this equation. So I get 0 plus 4. When I square it, that becomes 4. Square it is 16. Add 5 is 21. So my y-intercept is 21. And so my graph will look like this. My vertex at minus 4, 5. My y-intercept at 21. However, what happens if we've got something in front of the x minus a all squared plus b? So we've got a number here. So instead of having y equals x minus 3 all squared plus 1, you can have completed the square form where there's a number in front of the part in brackets. So let's have a look at what happens there. And of course, it could also be written as y minus b equals k x minus a all squared. It can be written either of those ways. Well, the vertex is still at AB. Vertex, if it's k is y equals x minus 3 all squared plus 1, the vertex there is going to be at 3, 1. 3 along, 1 up. Well, even if you've got a number outside the brackets here, you're still going to have a vertex in the same place. But other things will change. And one thing you have to be careful of is which way up the graph is. If the k number, the number outside the brackets, is positive, then you're still going to have a minimum. You're going to have a graph this way up. But if it's negative, you're going to find the graph is upside down. So let's look at two graphs. So the first one here, y equals 2 brackets x minus 3 all squared plus 1. The vertex is still at 3, 1. And the reason for that is the vertex is when this part comes to 0. Well, if I put x equals 3 in there, you're going to get 3 minus 3 is 0. Square it, it's still 0. Double that, it's still 0. And then you're going to get y coordinate is 1. So the lowest point is still 3, 1. However, it is going to cut the y-axis in a different place. Here, to get the y-intercept, I put x as 0, I get minus 3. Square it, becomes plus 9, add 1 is 10. Here, I do minus 3, because x is 0, so I get minus 3. Square it, I will get plus 9. Double that to 18, add 1. My y-intercept is 19. Now let's look at this one. This is with minus 2, x minus 3 all squared plus 1. So y is minus 2, x minus 3 all squared plus 1. Notice the k value is negative, so it's upside down. My vertex is still at the point 3, 1, still at exactly the same place, because if I put in x equals 3, I get 0 there, square root of 0, times it by minus 2, that's still 0, add on 1. So the vertex is in the same place, but it's upside down. To find my y-intercept, I put x equals 0 in here. Well, if x is 0, I get minus 3, square it becomes plus 9, multiplied by minus 2 becomes minus 18, then plus 1, it becomes minus 17. So the vertex, the y-intercept is at minus 17. Now that's in the completed square form. You can also have the graphs in the factorized form. So let's say we wanted to sketch y equals x minus 4 times x plus 2. Well, let's find our intercepts. If x is 0, then you get y is minus 4, because 0 minus 4 is minus 4 times plus 2, minus 8. So the y-intercept is where x is 0 and the y-intercepts will be minus 8. The x-intercepts, that's where y is 0. Well, if y is 0, then either x minus 4 is 0 or x plus 2 is 0. One of them must be 0. Because if two things multiply to 0, one of them is 0. Well, if x minus 4 is 0, x equals 4. And if x plus 2 is 0, x is minus 2. So my intercepts, my x-intercepts are minus 2 and 4. My y-intercept is minus 8. The graph is the normal way up, so it's going to look like this. Y-intercepts at minus 8, x-intercepts minus 2 and at 4. Okay, that's what it's going to look like. Let's pull it down a sec. You can see the equation underneath, because we always label the graph. Right, let's try some questions. First one, what transformation maps y equals x squared to y equals x minus 3 all squared minus 5? Well, let's rearrange it, this one here, to the form y minus b equals x minus a all squared. So all you do is you move a minus 5 across, it becomes plus 5. So you get y plus 5 equals x minus 3 all squared. Now, what's the translation going to be? Well, it's going to be a translation by, if we turn x into x minus 3, the a number is going to be 3. Y has been turned into y plus 5, so the b number is minus 5. So it's going to be a translation by 3 minus 5, because x has turned into x minus 3, y has turned into y minus minus 5. Y minus minus 5, same as y plus 5. Next one. The curve y equals x minus 4 all squared is translated by vector minus 1 minus 2. What's the equation of a transformed curve? And then we're going to do a sketch. Let's do the first bit. We have got to replace x by x minus a. So you're going to replace the x there by x minus minus 1 by x plus 1. You're going to replace the y by y minus b. So you can replace the y by y minus minus 2, which is y plus 2. So the y turns into y plus 2. The x there turns into x plus 1. So in the brackets you get x plus 1 minus 4 all squared. Well, that's the same as x minus 3 all squared, because plus 1 minus 4 is minus 3. So our equation is y plus 2 equals x minus 3 all squared. If I want to move the 2 across, I get y equals x minus 3 all squared minus 2. Now let's look at the sketch. Well, the vertex is going to be at the point 3 minus 2. And if I want to find the y-intercept, I just put in x as 0. 0 minus 3 is minus 3. Square it becomes plus 9. Plus 9 minus 2, 7. So there's my sketch. Okay, and I've labelled the vertex and the y-intercept. Right, finally, find some equations for some parabolas. So parabolas, quadratic graphs, are the shape as a parabola for it, okay? And we need to find the equations of each of these. So what we do is we look at it and we say, well, are we going to find the equation in the completed the square form or the factorized form? And normally we'll use one of those two forms because they're the most useful. Well, these ones here, these are going to be in completed the square form because we know the vertex. So what we do is we write down y equals, well, it might just be x minus a all squared plus b, but there could be a number here. But either way, we know the vertex here. So what we want to get is, for this one here, y is going to be k, some unknown number. The vertex is minus 1, 4, so it's going to be x plus 1. That one you change the sign, and the minus 4 we don't. So it's going to be k times x plus 1 all squared minus 4. Just plotting in the vertex. The vertex is AB. It's going to be x minus a all squared plus b. Okay? Now, let's see if we can find the k by substituting in this point, because if I actually put in, if I didn't have any k there, and I put in x as 0, do you see that what you get is you get 1 squared, which is 1, take away 4 is minus 3, but it's not cut at minus 3, so it's not going to have k here as equal to 1. So substitute in the point we're given, 0 minus 2. So that means replace the y by minus 2, replace the x by 0. 0 plus 1 is 1, square it becomes still 1. So what you've got is you've got 1 lot of k, take away 4. So you're told minus 2 is the same as k take away 4. Well, k will be, with the minus 4 across becomes plus 4, minus 2 plus 4 is 2. So k is 2, 2 take away 4, coming to minus 2, you can see it's working. So the equation becomes y equals 2 x plus 1 all squared minus 4. If we check that, you'll see vertex is at minus 1 minus 4, where we want it. Put in x as 0, and you get 0 plus 1 is 1, square it is 1, times 2 is 2, take away 4 is minus 2. So it's all working. Right, let's try the next one. Again, we know the vertex, so it's going to be the same completed square form, but this time we expect the k to be negative. Let's first of all put in the vertex. So vertex is minus 3, 6, so it's going to be y equals k, lots of x plus 3 squared, the minus 3 changes sign, and the 6 doesn't, plus 6. Now let's substitute in the other point we know, which is 0, 3 over 2. So you replace the y by 3 over 2, replace the x by 0, and so you get 0 plus 3 is 3, square it is 9, so you get 9k plus 6. So 3 over 2 equals 3 squared 9, lots of k plus 6. So we need to now find k, move the 6 to the other side. So you get 9k is going to be 3 over 2 minus 6. Well, if we want 3 over 2 minus 6, we'll turn the 6 into 12 over 2, so we've got a common denominator. So we get 3 over 2 minus 12 over 2, which is just another way of writing a 6. 3 minus 12 is minus 9, so it's minus 9 over 2. So 9 lots of k is minus 9 over 2. 1 lot of k must just be minus 1 over 2. Just divide through by 9. So k is minus a half. So this one, y equals minus a half, x plus 3 all squared plus 6. Again, let's check it to make sure we're right. So we go back to this. The vertex, minus 3 plus 6, yes. And now put in x as 0. 0 plus 3 is 3. Square it becomes 9. 9 times minus a half is minus 9 over 2. Add on 6, or minus 9 over 2. Add on 12 over 2 does come to 3 over 2. That's worked. Now this one here, we're not told the vertex, so instead we'll use the factorized form. Now because you see the 2 and the 6 there, you know y is going to be something times x minus 2 times x minus 6. Well, the last one we looked at was just straight to an x minus 2, x minus 6 on the previous page. But if I expand that, minus 2 times minus 6 is plus 12. It's not cut at plus 12. So it's going to be a k times it again. So y is k lots of x minus 2 times x minus 6. Let's substitute in 0, 6, and you get 6 for the y equals, so 0 here is minus 2 times minus 6 is 12 times k. 6 is 12k, k is a half, so our equation is going to be y equals a half, x minus 2, x minus 6. Check it through. When x is equal to 0, you get a half times minus 2 times minus 6, and that is going to come to minus 2 times minus 6 plus 12, a half of 12, 6. So now, what happens when y is 0? Well, y is 0, a half's never 0, so x must either equal 2, because 2 minus 2 is 0, or x equals 6, because 6 minus 6 is 0. So my x-intercepts are 2 and 6, so it has worked. So working the things out, always check at the end that your answer actually matches your graph. Okay, good luck.